unlike empirical probability, theoretical probability is going to be the idea that we don't necessarily collect any information. And what we're going to do is we're just basically going to compute probabilities based on what we think should happen. All right, so there's no experimentation, there's no collecting of data. We just use the definition of probability and we kind of go with the sample space and we just kind of compute probabilities that way. All right, so we're going to take a look at several different examples of being able to compute probabilities using theoretical types. And so we have, first of all, our first few problems, we're going to have a six-sided die, and it contains the numbers 1, 2, 3, 4, 5, 6. And we want to find the probability of rolling a 4. Now, this is what we think is going to happen. All right, doesn't mean that it is going to happen, but if I was to roll the dice, there is one number 4 out of 6 total possibilities. So that's theoretically what should happen, is if I roll the die, I have about a 17% chance, right? And I got 17% because I just went in the calculator and I just put in 1 out of 6, and that's just 16.66666 forever. So I just put 17% for that. Now, let's say we have the same six-sided die, contains 1, 2, 3, 4, 5, 6. We want to try to find an odd number, all right? So we know that in this roll, or on this die, we have 1, 3, and 5 are odd numbers. So there are 3 odd numbers out of 6 possible. All right, it's 6 because it's a six-sided die, and we know that that's going to be 1/2 or 50%. All right, so just be careful whenever you're entering your answers. If it asks you for the precise or the fractional value, 3/6, and if it asks you specifically for a percentage, then you give the percentage. We have a six-sided die, 1, 2, 3, 4, 5, 6. Find the probability of rolling a number greater than 2. All right. So we know that the numbers 3, 4, 5, and 6 are bigger than 2. And so there's 4 of those numbers out of 6. And if I were to approximate that, that's going to be 67%. And again, if you don't trust me, you could just go into your calculator and plug in 4 out of 6. Now we're going to change the scenario. We're dealt 1 card from a standard 52 card deck. Find the probability of being dealt a 2. And for those of you that don't know what's in a 52 card deck, a 52 card deck has basically 4 suits. So it has spades, it has clubs, it has diamonds, and it has hearts. And then in each of these, it has the numbers 2 through 10. Right? So basically 2, 3, 4, 5, 6, 7, 8, 9, 10. And then it has a jack, a king, a queen, a king, and an ace. Okay, and that's for all of these. All right, so 2 through 10, 2 through 10, 2 through 10, and jack, queen, king, ace. All right, so you guys get the idea. All right, so I'll just write them all out. All right, so there are 52 possible cards. So there are basically 13 spades, 13 clubs, 13 diamonds, and 13 hearts. And again, that's going to be 2 through 10. So 2 through 10 is 9 of these numbers. All right, so there's 9, 2 through 10, and then 1, 1, 1, 1. So that's how we get to the 13. All right, so this chart might be helpful whenever you're given these types of card problems. All right, now to be able to actually answer the question, which is ultimately what we're trying to do, it says, what's the probability of being dealt a 2? So I look at this, and there are 4 total 2s. So the probability is going to be 4 out of 52. All right, and if we went into our calculator, 4 out of 52 is going to be roughly about an 8% chance if I was to round that off to a single percentage. All right, so if you're playing a game like poker, or if you're playing a game like blackjack, and you really need a 2, the probability is not going to be very high in a standard 52 card deck. Right? Now the same thing, we're asking what's the probability of being dealt a heart. All right, so we know that in a standard deck, there are 13 hearts, okay? And again, we just know that because there's 9 and 1, 1, 1, 1. of Jack, Queen, King, Ace, and then 9 value cards. So this is going to be 13 out of 52. And I believe that's going to be 1/4 or 25%. But again, if you don't trust me, what you can do is you could certainly throw that into your calculator, 13 out of 52, and it's going to give you 25%. The final one we have here, you are dealt a standard or 1 card from a standard 52 card deck. Find the probability of being dealt a card greater than 5 and less than 9. All right, so again, we go back up here, spades, clubs, diamonds, hearts. So we have spades, clubs, diamonds, and hearts. And numbers that are greater than 5 and less than 9. So there's a 6, 7, and an 8. And there's a 6, 7, 8 of spades, 6, 7, 8 of clubs, 6, 7, 8 of diamonds, and a 6, 7, 8 of hearts. That gives us 3, 3, 3, 3, or 12 total. So that's going to be 12 out of 52. And we're going to get a number just less than 25%. So 12 out of 52 is going to be about 23% probability. All right, so it's 23%. And then the exact value is 12 out of 52, and the approximate value is 23%. So it's somewhat likely. It's reasonable to expect that that could happen. All right, with 23%. Same thing with 25%, but with 8%, it's not very likely that that's going to happen. So for those of you that like to play cards and are expecting to win or something like that by getting a number between 6 and 8, it's somewhat likely to happen, but probably wouldn't expect it to happen. Usually, if it's around 50%, then it's like about a half and half shot. And it seems like it might be worthwhile for you to go ahead and bet that. All right, so that takes care of our probability, and hope you enjoyed this video.